You're on a planet that's pulling you down. You can't get up out of bed. You're exhausted. You're slumped over. Those are the symptoms of depression.
Right.
Those are also the symptoms of too much gravity. What we're trying to do is fight gravity.
This is the missing link in biohacking, and it's maybe the most ignored of all of the signals because it's always present and we just assume it's there.
Brennan Spiegel is a director of health services at Cedars-Sinai and a professor of medicine and public health at UCLA. He has pioneered groundbreaking work on how virtual reality and emerging technologies can transform patient care. His vision is reshaping the future of healthcare and the way we experience healing.
Low blood pressure is a bad thing.
That's a gravity intolerance problem. Passing out, feeling dizzy, low back pain, ankle swelling, even depression and anxiety are forms of gravity intolerance.
I used to weigh 300 pounds. Is obesity a gravity disease?
You're listening to The Human Upgrade with Dave Asprey.
If you think about the definition of biohacking, it's the art and science of changing the environment around you and inside of you so you have control of your biology and control of your state. And of all the different variables, we have light, we have sound, we have vibration, we have food and timing, and gravity is one of them. And it's maybe the most ignored of all of the signals because it's always present and we just assume it's there. And I've been interested in hacking gravity, levitating too, but that's not what I'm talking about. If we learn how to do that in this episode, I'll be surprised.
Yeah.
But the signal of gravity is something that is a very strong signal to the body. And it's something that we manipulate with the cheat machine at Upgrade Labs, where instead of fighting gravity, you're fighting an AI system that does weird things to you. But I haven't been able to find a researcher. There's people who look at gravity and planets and things like that, but what is the direct signal of gravity on the body? How does it affect us? Well, I found a guy, and he's legit. Cedars-Sinai, very well published. And this is a big deal, I would say, at least in our study of the whole universe of what we can tweak. Why gravity?
Well, you just said it. Gravity was here long before we were. It's going to be here long after we're gone. So it stands to reason that every part of your body, every sinew, every cell, every organ evolved to manage this fundamental force of physics. We are to gravity like a fish is to water. A fish is designed to survive and thrive through this aqueous liquid world. I don't know if it knows that, but that's what it does.
Right.
We are the same way. We don't think about gravity much, but every part of you right this second on a microbial level, on a microtubular level, and on a macroscopic level is trying to stand up and stay up as long as you can and as well as you can.
So being alive is basically resisting gravity?
That's almost all it is. There are only 4 fundamental forces in the universe as we know it. One of them has to do with stars. One of them has to do with us not exploding, right, like as we're talking.
It's always a problem.
So once we got that situated, it's about electromagnetism and gravity. And that's what we're talking about today is the gravity side.
All right. You make the case in your book that medicine ignored gravity. That seems like a big thing. How did medicine end up ignoring it?
We spend a lot of time learning about the individual organ systems and how they work. But we don't talk a lot about what they're aiming to achieve. What we're trying to do is fight gravity. Like we literally emerged from this planet. We are grounded on this rock, and we are a consequence of it. And so all of our biology, physics came first and biology second. And nowhere in medical school did I hear that. We came out of the earth. It's basically came out of the oceans, which is something we might want to talk about. And we evolved all these pumps and tubes to keep the hydraulics so that you can stay awake and talk with me and have your brain getting oxygen.
Yeah, low blood pressure is a bad thing.
That's a gravity intolerance problem. Passing out, feeling dizzy, low back pain, ankle swelling, even depression and anxiety, I argue in the book, are forms of gravity intolerance.
So highly resilient people resist gravity better, you're saying?
Physically, metaphysically, resist gravity better, yeah.
What does metaphysically resisting gravity really mean?
Well, what I mean by that is there is a part of us that is hard to identify in physical space. And we can get into philosophy. I was a former philosophy major.
That explains a lot. Okay.
Yeah. But what I mean by that is even consciousness itself, which is hard to locate in space and time. is, I argue in this book, also very much a consequence of our relationship to gravity itself.
Fascinating. When you get into some of the more quantum consciousness, cutting-edge philosophy books, they're making the case that time and space, at least, are hallucinations that our bodies create. Is gravity one of those too?
Yeah. So consciousness itself is sort of a controlled hallucination, in essence. And it's a narrative that we construct in our mind using the signals of the universe.
Right.
So right now, we talked about two of those signals, electromagnetism and gravity. So we are sense-making machines. Right now, your body is taking in, billions of data points. The pressure on your bottom, your cerebral spinal fluid in your brain is dependent on your elevation related to sea level. We can go through lots and lots of examples, but you're taking in all of this data. And like a computer, you're compressing the data down more and more at each level. You compress it and compress it again through your nervous system, and it eventually ends up in the brain as a mental map of your relationship to this planet. And then you're making sense of it in relation to the physical reality that we're in as we understand it. And that's what we do. That is how we survive, is by creating a mental, perceptual understanding using the data like a compression engine. And then from there, it's all dependent on the decisions we make and how well we support this body to stand up and stay up until eventually we're pulled back down again.
Wow. That's a very different view of living and dying and being conscious, but it maps. It makes really good sense. Okay. How would I know if my anti-gravity system was breaking down? What's the first sign?
So I think of it like there's different stacks in your body. Okay. So the first is probably the most obvious, which is the musculoskeletal system. What is lower back pain if not a form of gravity intolerance? We originally were four-legged creatures.
Yeah.
And only in relatively last part of our evolution did we stand up and change our relationship and center of gravity completely. And then all of the viscera started dangling down, and your spine became this chassis that had to hold up this sack of potatoes that you've got in your belly. I'm a gastroenterologist, so I think a lot about this. And so that means you have to have a strong back in a way that four-legged creatures don't. And back pain is a form of gravity intolerance. Pain itself, chronic pain, is often a form of gravity intolerance. It's a way of your body telling you you're literally not aligned with this downward pull or upward push, depending on how you look at it, of the planet itself. So those are just a few common explanations of gravity intolerance. But then if we dig deeper, there's something called tensegrity, which is tensile integrity. So, Tom Brady played for so long, not because he was the biggest guy. It's because he was the most durable, zipped up guy.
His fascia was working.
His fascia was tight. And so resilience is about bending and not breaking. And in the body, we have all these organs that we learn about, but it's actually the in-between space that we rarely ever talk about. It's the connection points within the body where one system connects to another. It turns out a lot of disease begins at that point. And if you toughen that part up, you toughen your gravity resilience too.
Are there things that you've learned that we can do to make ourselves stronger in that way?
Yeah. So starting again, we're talking about this first stack of the muscles, the tendons, and the connection points.
Right.
So in the book, I called it Operation Gravitate. So I decided to wear a weighted vest for 8 weeks.
So cool.
All day long. I've got pictures of it in the book. I wore it to meetings. I also wore a 20-pound ankle weight on each ankle.
Smart.
Standing desk, balance board. So all day long, that's what I'm doing for 8 weeks.
Big amount of work.
It's a lot of work. At first, it was exhausting. But as a few weeks went on, I found this strength from within that I'm not accustomed to. I run marathons and I'm somewhat athletic.
So you're a masochist kind of.
Yeah. But I actually found it was very difficult to just stand there with a weight. It was like simulating life on a bigger planet with a stronger pull. And at the end of the day, when I pulled all the weight off, I felt buoyant. I felt almost like I was floating.
About 12 years ago, very early in the biohacking movement, I bought something called the anti-gravity suit. And this is a weighted vest that included arm weights around the elbows and wrists and ankles, knees as well. And the inventor of this anti-gravity suit, it was ridiculously expensive, like $1,200 or something.
Right.
And it looks so stupid, like a blue padded superhero outfit. So I went for walks with it for a month or two. But I'm not wearing this all day long. I just can't do that.
Yeah.
But I did notice some similar things. It felt like it was also affecting my proprioceptors. And for listeners, proprioceptors or proprioception is your body's sense of where it is in space. Just because if you don't know where your hand is and there's an extra weight on it, you're going to flop around. The same with your ankles. Do you feel like your nervous system changed in addition to your muscles and your posture?
So we call this graviception.
Ooh. So
proprioception is part of graviception. Graviception is your perception of gravity, and it comes to you in different ways. So you have these Golgi apparati that are constantly keeping track microscopically of your angulation of your muscles and tendons. That informs your proprioception, which I train with a balance board when I'm standing with the weighted vest. But it's also informing your brain in an area called the anterior insula, which is actually a graviceptive center in the brain.
Oh, wow.
That is like a control panel that is literally taking in the signals from your inner ear, your proprioception, and even internally inside what we call interoception, and creating this mental map of gravity, which we talked about earlier. And so by doing what I did, I was training my graviceptive experience of the world and really bringing myself to a different understanding of what it means to live on a 1G planet versus, a 1.2G planet, let's say.
Wow. One of the things that intrigued me about your book is I've been thinking about space travel a lot since I was a kid, and I read a lot of science fiction. And I had a chance to ask the president of SpaceX at an event. So you've hardened all of your electronics for space travel, right? What have you done to harden astronauts?
Yes.
And she looked at me and she said, in 17 years, no one's ever asked me that question. We're not doing anything. And I'm thinking to myself, going to Mars is an absurd thing because we haven't solved the gravity problem.
That's right.
And when people get to Mars, their vision will be gone because of gravity.
That's right.
Their brains will be gone because of gravity. Yeah. And they'll be unable to reproduce, probably because of gravity and maybe radiation. Why do all those things go haywire in space?
So we were born on this planet. We were born with gravity. And there's sort of this gravity Goldilocks zone. Too much gravity for your body could be bad. Too little can be bad.
Yeah.
And this not only is in microgravity orbit, but even in high altitude or even in an airplane. So we might even talk about that. But we can learn a lot from what happens from astronauts and apply that back to our Earth here, our life here in the atmosphere.
Well, airplanes don't lack gravity, do they?
Well, so the pressurized cabin is about 8,000 feet, and so
that's a pressure versus gravity.
So gravity itself isn't too different as you get that far out, but it's squeezed on the atmosphere.
Okay. So atmospheric pressure is an aspect of gravity.
Absolutely,
okay.
It's a consequence of gravity.
Now I'm with you.
So it all comes down to gravity. That's how fundamental it is. So yeah. It's very much a gravitational effect. Jet belly, people with inflammatory bowel disease get colitis flares when they get up in high altitude. Serotonin biology changes, microbiome changes, and all that happens in astronauts too. So it turns out the microbiome and its diversity changes in microgravity orbit. Serotonin biology changes. And what happens also is just the fluidics, those pumps and tubes. There's a redistribution of fluid that leads to more congestion in the head, headaches, eye issues, kidney stones, and really interesting, infections start to come out in this place that's been scrubbed clean. Why would astronauts get viral infections? And all that stuff happens in space.
Okay, let's make this practical. When people are flying, how do they minimize the effects of this lack of pressure from gravity?
Yeah. So if you ever have had like a snack bag or chips or something up at cruising altitude, you'll notice that they're taut with air.
Yeah.
And you can almost imagine that's what's happening in the organs too, especially the gut. Will start to stretch out a little bit. And it can be very uncomfortable for many people.
Unless you just don't eat all those beans.
So what you eat ahead of time, watch some carbs, have some, loose clothing. But one thing is there's something called the jet belly release. That's what I call it anyway, where you take your hand and kind of push it just under the belly button. And then you want to milk it like towards your right hip. And what you're doing is you're taking the gas in the small bowel and pushing it through the ileocecal valve into the colon. That's just a few little things you can do.
I used to do that, when my kids were really young. We just, I love you. And you do this like inverted U shape, ascending, transverse, and descending colon. And man, they sure did fart a lot. But
there you go.
What I've found, and I'd love for you to poke holes or comment on why it works, is most people have heard you should wear tight socks to keep blood from pooling in your legs, right? And so I would do that. And then it was Nick Foles, the Super Bowl champion, came on. He said, "No, Dave, I fly even more than you, and I fly a lot." And he said, "Just wear compression tights and a shirt." I said, "Seriously, a shirt?" I said, "Yeah." So I tried it. And I have super tight compression tights and a compression shirt on when I fly, and I have zero symptoms of any of this because I replaced the pressure that's not there from gravity.
Right.
And it's totally changed my resilience. My brain works better. I don't get any of the flight stuff.
Absolutely. So, you say your brain works better, and we might even talk about why we sleep, because you're reperfusing your brain at night. Literally, that's a gravitational effect too. We need to keep, that's why you got to drink a lot of water. This is why Alzheimer's disease is in part related to blood flow and how many orthostatic symptoms you have and how much fluid you drink and your salt levels. They're all part of gravity management. And so I'm going off on a little bit of a tangent, but it comes back to what you just said. On an airplane, if you don't stay well hydrated, if you don't have compression of the pumps and tubes, you're not going to get that venous return up to your brain. You start feeling a little bit sluggish, a little lightheaded, some brain fog. That's gravity.
Wow. You mentioned a lot of things there. So we could have some sodium-based electrolyte would probably be a good idea. I do that when I fly. I do carbonated water, which isn't really for pressure. I do that because increasing CO2 in the body increases your body's affinity for oxygen. And I've actually measured the change on an SpO2 thing after a lot of experiments.
Okay.
So I think, yay, carbonated water, no to Coca-Cola. But you might burp, but you're unlikely to get bloated from that, at least from my experience. And then I'll do creatine, which is all, these are all just increasing the amount of fluid so they don't have those problems.
Right.
And then I do a couple other weird things. I control the lighting environment, and I wear a shirt that helps to block EMFs because those are probably bad for voltage-gated calcium channels, but I don't think it makes that big of a difference. But what the hell? I'm on an airplane. Who cares? I also take a ketone beverage to protect my mitochondria. Because we know that the presence of ketones in mitochondria reduces ionizing radiation effects, which would cause cell swelling, which are part of this whole thing. Do you think it's possible to have a good microbiome with zero gravity?
I mean, that's an open question because those critters inside of us, the trillions of them, also evolved on this planet.
Right.
Mainly in the ocean, by the way.
With gravity and motion.
So it's worth telling the story here real quick because it gets us to your question. We think life evolved in the oceans, probably around hydrothermal vents, hot, gassy, sulfuric, dark worlds.
Basically outside Taco Bell. Okay, that was
something
fun.
like that. So we eventually emerged from the oceans in these amphibious forms, and we needed to find another dark Taco Bell-like sulfuric gassy place, and that was the gut. We created a hydrothermal vent in our
body. That's interesting.
To give a refuge to these to the microbiome, which we now call it, which we co-evolved with. And what did they give us? They gave us serotonin. And we gave them the ability to move around the world. Right. But we needed serotonin to do that because serotonin is a gravity management substance. That's what it does.
Okay. I've heard of it as a cell signaling substance throughout the body. It's not just in the brain. In fact, most of it's not in the brain.
Deeper than that. It's more fundamental.
It's like a mitochondrial stress signal.
Yeah.
And you think gravity drives serotonin?
100%. Yeah.
Okay. Been using whole body vibration plates for 15 years and used to manufacture them. Is that affecting my serotonin levels? Because you're affecting gravity with acceleration.
I don't know. Wow. That's a really interesting hypothesis.
You're blowing my mind here. Okay. So tell me more about serotonin and gravity.
I've written a couple papers on this, so this isn't...
I'm believing you. You're as credible as it gets in this field.
So, let's just think about most people, when they think of serotonin, they think about a happy chemical. It's in the brain, and it elevates your mood. By the way, elevate is up and depressed is down, so that's gravitational in a way. We'll get to that.
Wow.
And the verticality of our neuropsychology, we can get to that. But 95% of the serotonin in your body is not made in the brain, it's made in the gut. And it relies upon your microbiome. And we can talk about how to boost serotonin through diet and all that. But basically, when you look at what serotonin does, without it, you would be a flaccid sack right now. I mean, like a baby has very little serotonin in its body. It hasn't developed its microbiome yet. It's a flaccid sack. Babies they can't move.
Yeah.
What serotonin does is it primes your pumps and tubes. It helps you contract your vascular system. It helps your baroreceptor reflex, which is in your aortic arch and carotid. You have these pressure gauges that determine if you need to increase or decrease your blood pressure based upon your rising and falling and your fluid status. And that's all serotonin. Your inner ear, which keeps you from not falling over, serotonergic, which is why people who withdraw from SSRIs get very dizzy sometimes. We can go on and on. Lymphatics rely upon serotonin, even that interstitium and the fluidics within the interstitium. Basically, without it, we wouldn't be able to move stuff up. And there are more examples than that.
Wow.
And so if you think of it that way, what it's really doing is allowing us to fight gravity.
Does this mean that psychedelics and MDMA are gravity drugs?
Yeah, and you feel high.
Whoa, okay.
You literally
incredible.
feel high.
Wow.
You are floating. Psychedelics explode serotonin in the brain.
Yeah, yeah.
And the felt experience we call
floating.
high.
Yeah.
Okay, and
Wow.
so I'm feeling high. I mean, you think about the words we use in our language. Looking up to the heavens, I look down to hell. I'm feeling down in the dumps. I'm feeling high. And you look up to, church steeples or
That's why tall people are better, you're saying?
I don't know about that. You are pretty tall, though.
I'm just kidding.
So, yeah, no, I mean, it might even be, to be honest. Like, there is a verticality in how we think about the world.
They get elected more. We know that.
For sure. And actually, there's, and all jokes aside, there's all this psychological research that if you go to a market and something is stationed on a higher shelf, we consider it worth more money than if that same object is in a lower shelf.
Isn't that crazy?
Yeah.
Wow. Okay. I had never thought about this. You're giving me a new way to see things. Thank you.
Yeah.
I've seen people use rebounding, which provides a brief period of what feels like a lot more gravity at the bottom of a trampoline. Mm-hmm. Is this a form of gravity therapy?
Yeah. The title of the book is Pull. Mm-hmm. But really, gravity is a push up as much as it's a pull down.
Yeah.
That's what relativity refers to. It's not like the Newtonian form of gravity where we think we're being like pulled down by some silent hand. Or invisible hand. It's the warping of space-time around an object, and it's all relative. So what I'm getting at is, for example, when you run, and I happen to run in these Vibram 5 fingers, because I want to feel the ground. That is a gravity management surface. Your foot is a gravity management surface. It's 5% of your body surface area that takes your entire body weight. So we need to build that up, because what you're really doing is there's an upward push.
Right.
And you're trampolining off of the ground, like this trampoline exercise you're describing. We're actually using gravity as a buoyant force to push us back up stronger into the world, not to be sucked into it.
So does this mean that padded shoes make you weak in gravity?
Yes.
Good.
Chapter 1's all about that.
I have taken so much flack for wearing 5-fingered shoes to the point that I put little chrome studs on each toe so they'd be fashionable. It didn't work.
I love it.
But yeah, I don't wear padding in my shoes. I wear Vivo or Peluvo these days because it's the only thing that makes you feel good in gravity.
100%.
I love it that you're getting into this.
I've run 10 marathons in those shoes.
Amazing.
I shaved 20 minutes off my marathon time.
Well, most people they try to do it. They say, oh, everything hurts. I can't do it. And they get all whiny. Why?
Well, it has to do with whether you use the shoes correctly. Now, to be clear, people can injure themselves in these shoes.
100%.
Okay? So let's just be clear about it.
You have to relearn how to walk,
yes,
correct?
There's a technique to it. And in fact, in the book, I talk about my experience in these shoes, because gravity management begins with the feet.
Yeah.
And so the problem is when you wrap your foot in a shoe, the temptation is to heel strike. Mm-hmm. And the calcaneus, the hard heel bone in the back, is really not designed to be the point of contact for running. It's there so if you're standing upright, you don't fall on your butt. Right. It's like a tripod. Mm-hmm. When you're running, you're supposed to flare out your toes, almost like almost like a swan coming in for a landing on a lake. It's like reaching out to grab the surface. And if you look at elite runners, their toes are contact points that grab the earth and propel off, and the force is on the forefoot. And that requires a trampoline-like explosion across the fascia. And you can't do that very easily if your foot is completely like filled up with padding all around it.
Yeah.
So yeah, that's why I wear the Vibrams.
I've spent the past really like 4 or 5 years completely learning how to walk differently. And I've been wearing these shoes for almost 15 years. But I just never learned when I was young because of padded shoes and whatever else. But it's really changed how I move in the world.
This is the Alexander technique, if you're familiar with that. And this all started from an Australian stage actor, and I forget exactly what year, a long time ago, who had lost his voice. And he was losing his career because he could not speak.
Right.
And he finally figured out, after all his trial and error, that it had to do with the position of his torso, which had to do with the position of his legs, which had to do with the position of his feet. And his entire mechanism, as he put it, was misaligned with gravity. And once he reoriented, he got his voice back. And so that started the whole Alexander technique. And they talk a lot about grounding with your feet.
It's all connected, like you're saying, through gravity. Talk to me more about gravity in the gut, things like Crohn's or IBS. What do we know?
Well, I mentioned a little bit before. There's not much known. We do know that people with Crohn's disease can get flares at higher altitudes, whether it's in an airplane, that can trigger a flare, or just living at higher altitudes. So where you are on the planet may have something to do with your gut health. It's interesting, by the way, that Crohn's varies by latitude. So does MS. There's a number of conditions that vary by latitude.
Vitamin D thing or gravity?
Well, we don't know. We've always thought maybe it's vitamin D, but no one's really ever talked about whether it could be slight variations in gravity, because as you move across from the equator to the poles, gravity does change. Very slightly.
Wow.
Very slightly, but that's all we've ever known. And so it may be that changes in gravity, like on the globe itself, where you are altitudinally and latitudinally, can affect your health.
You ever have one of those days where the universe just lines things up? The guest who was just here, who you met on the way out, Roland McCready, has the largest and most detailed data set on planetary gravity of any human on Earth. It's used all over the place in research. Well, he's buried sensors all over the planet and correlates them to figure out the magnetic field and gravitational field of the Earth.
Well, also HRV is a measure of gravitational fitness, and so is the vagus nerve.
Wow. And Stephen Porges has been on, and I even work with a vagal nerve stimulator called ZenBud, where I'm an advisor that does ultrasonic stimulation of the vagus nerve.
In the ear? And the auricular? Yeah.
So why do you say the vagus nerve is tied to gravity?
Yeah. So we use it, by the way, for Crohn's disease, to finish up that discussion.
The vagal nerve stimulator?
Yeah, we're starting to use that because it can boost serotonin levels in the gut by activating the vagus nerve in the brain and in the gut. So the vagus is involved in serotonin stimulation, and it's sort of like a spigot in the body for releasing serotonin in a controlled way. So in that regard, it has to do with gravity management, because I've already explained how serotonin is a gravity management substance. But when you breathe in and breathe out, right, this HRV is about not just the rate, but the beat-to-beat variation, the real rhythm of your inner symphony, really.
Right.
And what's happening is you've got two pumps that are yoked to each other, the lungs and the diaphragm, and the heart. And when you breathe in and you're upright, gravity pulls the blood to the bottom of your lung.
Okay.
That's where oxygenation is maximized. The lung is actually designed in the human to optimize oxygenation at its base, because we're usually, and when we need oxygen, we're upright. And so when we breathe in, the lung pools the blood. The heart gets less return to it because the lungs are holding on to all that blood. And so the rhythm of the heart is going to change to kind of keep up for the changes in flow. And then when you breathe out, you're extruding this load of oxygenated blood into your left ventricle, and it's going to pick up, and then you're getting it right up in your head, which is just what you need. If you're about to fall asleep, you want to yawn. A yawn, in essence, is getting you blood up into your brain. And the heart rate variability is looking at how well synchronized these two pumps are, in essence. And so in an indirect way, it's really telling you how well you're managing gravity and your relationship to these two pumps and how they move the fluid around, basically. So that's a long-winded way of explaining it.
That is really fascinating. I wouldn't have thought you'd answer it that way.
Okay.
One of the other things that's just been fascinating in the field of biohacking, and as opposed to medicine, biohacking is like, how do we make it better than it was before, versus how do we heal someone necessarily, though sometimes there's overlap, right? And a lot of the techniques are non-medical and some of them are. But cell membranes themselves are piezoelectric. And for listeners, piezoelectric just means when you put pressure on it or it moves, it makes a small electrical current. And our bones are particularly piezoelectric.
That's right.
In fact, that's probably how bone healing and certainly how bone density happens. So how important is piezoelectricity in the gravity story?
Man, you set this up so well. So the piezo channels were first observed, I think, in 2010. And there were some scientists, I believe in San Diego, maybe the Scripps Clinic, that were kind of poking on cells and noticing that there were these voltage gates that open and close in relation to physical tension.
Right.
And the way I actually think of piezo channels, and I've actually talked to the Nobel Prize winner who invented it, I think of it like a conversion engine or maybe a translation system to take gravity and convert it into electromagnetism in the body.
What a great and elegant way to explain it. Wow.
So we are, as I said before, sense-making machines. You're getting affected by the pull of the planet or the push, however you want to think about it, space-time curvature that we're all in. Your body has all of this apparatus, and it takes this physical stretch and movement and push and pull. And at the level of the cell membrane, the piezo level, it's converting it into bioelectric signals. That's what it does. And so if that handoff is broken, you can only imagine how difficult it is to survive and to thrive on this planet. So there's been research looking at what happens when you lack piezo channels. It's just, I mean, it's terrible. But if you have well-working piezo function, you now are getting that map of the world sent to your brain and to the insulin, all the stuff we talked about before. So that's how I think about piezo.
And that ties in cell membrane function, which longtime listeners know I'm kind of a mitochondrial fetishist. So I'm always talking about membranes and membrane composition and cardiolipin and how you can manipulate them and make them stronger. But I've never in my life considered cell membranes as a piezoelectric gravity conversion system. Is obesity a gravity disease?
For sure.
Okay, talk to me about it.
For sure. So the mesentery is this sheet of tissue that is another one of these seams. We didn't think much of it. We thought it was just this tissue plane that holds up everything on the inside. What it is your gut is hanging like off of a drape. And it turns out the mesentery is an organ unto itself. It's metabolically active. It's very involved in diabetes, for example. And if it gets caked up with adipose tissue, which is what happens with obesity, it starts to throw off not only the function of the gut, the way the system hangs down, but it also affects the metabolism of the body, and then the liver gets involved, and then you're into something. Obesity is not just about the subcutaneous fat, under the buttocks or arms. It's about what's happening in the pumps and tubes. And if that system is caked up,
the visceral fat.
Yeah, the visceral fat, you're going to have trouble fighting gravity. Not only because the muscles and bones are straining under the excess weight that they're not accustomed to or don't want. It's like you're living on a planet that's larger. And so now you can see, why would people get depressed? Well, if you literally feel like you're on a planet that's pulling you down, you can't get up out of bed, you're exhausted, you're slumped over, those are the symptoms of depression.
Right.
Those are also the symptoms of too much gravity. It's one and the same. And
so depression and obesity are gravity illnesses.
Forms of gravity intolerance.
Wow. Okay.
Yeah. So there's a guy, Lachlan Kent. He's a friend of mine. We're about to start a new podcast called The Gravity Doctors. And he's in Australia, and he created this whole idea of mental gravity. And the idea of depression as fallen and anxiety is falling. So when you're on a roller coaster and you fall, you get gut feelings, your butterfly, your stomach lights up.
You do feel it. Okay.
Feel it. Why is that? It's like you have a G-force accelerometer in your gut telling you you're about to die. That's what's happening on a roller coaster. And my patients with irritable bowel syndrome, they often don't want to ride roller coasters because they feel that all the time. They don't need to ride a roller coaster to get gut feelings. Their G-force accelerometer is telling them they're falling. It's a metaphorical fall.
Right.
Like we co-opted the gut to tell us when you're about to get into trouble. And so obesity only worsens that process. You see so much depression, so much, not just the arthritis, not just the cardiovascular problems and the edema. Those are all the back pain. All of those are forms of gravity intolerance. That's how I look at it.
What are things like micro movements, fidgeting? When people stand at a desk, they're actually shifting from one foot to the other. We're all rotating in a small cone that we don't see all the time. What do those have to do with gravity?
Well, we have a very unusual center of gravity as humans compared to four-legged creatures, which with a much more stable base. Our base is not stable at all. That's why people fall a lot. I mean, falling is gravity intolerance, right? We have to be very, very careful about our relationship to gravity because we're so tall and the middle is so easily eccentric or can be thrown off. So eccentric activities within a cone of safety is going to keep you really like aware of your relationship to the earth at all times. And you do want to do exercises in general. This is more fidgeting, but you want to do exercises that keep you off balance so that you're able to constantly use contralateral muscle groups to maintain your center of gravity. And if you can't stand on one leg for more than 10 seconds, that's actually concerning. And there's some evidence, now I'm not saying for your listeners, like, worry if you can't do that, but there's evidence that if you can't do that for more than 10 seconds, it is tied to longevity. And so maintaining 100%. Proprioception, balance, inner ear strength, this is all about maintaining gravity management.
It's a pretty good test, actually, because if you have fascial issues, if you have muscle issues, if you have neurological issues, vestibular issues, it's going to pick up one of those.
That's right.
Right. So
it's a holistic test.
Yeah. It's very rolled up of a lot of different data points.
Like a meta test.
Got it.
Yeah.
So if you're listening to this, you should definitely practice standing on one leg so you can falsify your data. Oh, wait.
Don't fall down. Make sure to hold on to something.
But in all seriousness, one-legged cable pulls across the body, those are really hard to do. Yeah. They're really good for the nervous system, right?
Yes.
And those are, I guess, a form of resisting gravity. Anytime you're doing weights.
Yeah,
really
intensity
gravity.
Okay. Right. Band training, the stuff that, Brady used to do.
I'm really impressed and enjoyed your book greatly. And guys, if you're listening to this and you like it, the book is called Pull, and the author is Brennan Spiegel. And thank you, Dr. Spiegel, for coming on the show, coming to Austin. And you give me a lot to think about. I really appreciate it.
Well, you have too, and that's a sign of a good conversation. So I appreciate the opportunity.
See you next time on the Human Upgrade Podcast.